Okay, so we've got number 13 here to work. This is a calorimetry problem. And so if you read that problem and you realize what I talked about is that you're really going to have two energy conversions to do. Both are involved with this equation here. All right, so what we're going to do is we're going to find the, or use the, find the Q of the water, and then we also have the Q of the metal. Okay, and you have to realize that in your equations you can only be solving for one variable. If you have two variables that were not solved for, then you can't solve that problem. You have to solve the other one first to solve for the one that has two variables. All right, so Q of the water. Let's take a look at that, and the mass of that is going to be 140 grams, and then we have the specific heat of that water being 4.184. I'm not going to use any units right now. And the temperature difference, delta T, is going to be 4.6 degrees C. So there's a unit for you right there. So we can find the Q for that because there's only one variable to solve for, and that's the heat. But if you look at the metal over here, we can write down our variables and the values for each of one of them. We have 100 grams of the metal. We have a temperature difference of 70.4, so I'll put delta T down there. And then we have, we don't have specific heat of that yet. And we certainly do not have the Q for that. So you see we've got two variables that we cannot solve for unless we have one of them. We can't solve for the metal at all. We got to solve for the water first. And so what we've got to do is write down an equation and then substitute our numbers in there. We have 140 for the mass, 4.184 for the specific heat, and then 4.6 is the temperature difference. And if you solve for all that, let me see, I changed my calculations because I didn't use 4.184, I used 4.18. I was getting lazy and not rounding. So let's see. We have 140 times 4.184 times, 140 times 4.184 times 4.6, and that gives us 2694.5, and that's joules. So if that's our answer for the Q for the water, that's going to be our answer for the Q for the metal, because you have to remember the Q in must equal the Q out. So whatever the Q for the water is going to be, that's going to be the Q for the metal. So 2694.5. And now you can solve for the specific heat of that metal. And I'll do that in green. So the specific heat, when I rearrange the equation, comes out to be, let's see, specific heat is going to be Q divided by mass times delta T. And they'll substitute those numbers in. 2694.5 divided by, let's see, the mass, which is 100, and 70.4 is the change in temperature. When you solve all of that, it comes out to be 0.3, well, no, let me do that again because I changed my numbers. 2694.5 divided by 7,040 equals 0.382 joules grams degrees C. That's the specific heat of copper when you look at your table. And there you go.